SmartSwitch Technologies of New Zealand design and manufacture systems which monitor and control vessel functions for both pleasure and commercial craft. These include bilge monitoring and pump control, tank monitoring and pump control, marine toilet control, navigation lights monitoring and control, vessel operations alarms, and systems using text messaging to monitor and control vessel operations. This represents a comprehensive set of solutions for vessel monitoring and control. The subject of this video is navigation light monitoring and control, and includes a demonstration of a system which was applied to a large fishing vessel which operates in the Bering Sea. SmartSwitch offers two models of navigation light control and monitoring. The first is the NV2000, which is for monitoring only of up to 32 navigational lights. The second is the NV8000 for both monitoring and control of up to 16 navigational lights. These systems have various features in common, including visual and audible alarms for any detection of a bulb failure, power failure, or a wire break. Provision has been made for a twilight monitor to turn lights on at dusk. The system has been designed to allow detection of currents as low as those drawn by one LED, and all alarms are generated with the name of the light that has had a failure. The NV8000 allows control of lighting from a central display panel. Since every activity requires a unique set or pattern of lighting, the NV8000 allows up to 12 groups or patterns depending on the activity, and in the case of a commercial fishing boat, these patterns might include such things as fishing and trawling and a variety of other situations. When the transition is made from one activity to another, a single button is pushed to turn all lights on associated with the new activity. What follows is a demonstration of the model NV8000 navigation light control system. The demonstration unit was built for training purposes for the owners of a large fishing boat fleet which operates in the Bering Sea. The destination boat is classified as a trawler catcher, approximately 130 feet in length, and has a navigation light configuration of 13 lights in 10 different groups. To allow an accurate representation of the lighting patterns required for this boat, a matrix was constructed showing the navigational lights across the top and the various operations requiring unique lighting patterns. Notice that any light can be assigned to any group, and several lights are assigned to multiple groups. Here is the simple demonstration and training panel that was constructed for this project. The entire system consists of three components. The first being a display unit mounted at a convenient location on the bridge, and the other two being input-output units which control and monitor the lighting. These can be mounted up to 1,000 meters from the master display. This view of the master display shows its normal operating condition when navigation lights are on. The system is continually scanning the lights to detect any failures. In the event of a failure, an audible signal is accompanied by a visual display showing the light that has had a failure. Sealed push buttons on the display panel allow the muting of an alarm signal and the selection of various lighting patterns. Other standard display screens include a navigation lights off screen and the screen that's used to select among the various lighting patterns. The other component on the demonstration unit is the NV100 input-output unit. It can accommodate up to 8 navigation lights. This system requires 13 lights, and therefore 2 input-output units were included. Finally, the MMIC panel itself is shown. Each of the navigation lights is represented by an LED. In this case, the steaming group was selected, meaning that the white masthead light, the port and starboard light, and the stern light were required to be lit. In a similar fashion, not under command and not underway was selected to light the 2 fishing lights indicating this activity. And when towing was selected, the 2 white fishing lights were lit, in addition to the port and starboard and stern lights. Here we start with all navigation lights off and turn on the steaming lights. Immediately the system begins scanning all lights for any failures. When operations dictate that a change be made in the lighting pattern, the enter button is pressed to display the menu. You scroll to the proper lighting pattern and press enter. All the lights associated with that lighting pattern are now being scanned for failures. In a similar fashion, as conditions dictate, each lighting pattern is selected from the menu, and with a push of a button, all lights associated with that pattern are lit. A critical feature of the system is the ability to monitor lights, including LED lights, for failure. And here we simulate the failure of a port navigation light. After the audible alarm is muted, the indication of the faulty light is maintained on the screen. Not until that light is repaired does the system go back to its normal scanning operation. As was shown, the system is easy to use. It's robust in design and manufacture, being built for a life at sea. And lastly, economical, applicable for both commercial and pleasure boats. In North America, Smart Switch products are sold by Marine Control Systems. We provide product, technical assistance, and programming, including integrated system testing for the products that we ship to our customers. Our contact information, along with details of all the Smart Switch products, can be found at our website www.marinecontrol.info.